Have you ever felt like your AI assistant just can't keep up when you need something long? You ask for a report and it gives you like a sentence.
Yeah, it happens. They can struggle with generating really long text that's also, actually good. Maintaining quality over many paragraphs is tough.
Exactly. It's like they run out of steam. But you sent over this really interesting research paper on something called block diffusion language models, BD3LMs.
That's the one, BD3LMs. Sounds a bit technical, I know.
It does. But the core idea seems promising, right? A potential fix for this whole long text generation problem, especially if you're someone, who just wants their AI tools to write better without needing a PhD.
Right. Think of it as a hybrid. It tries to combine the best bits of two main ways AI currently writes text.
Okay, so what are those two ways?
Well, first you have autoregressive models, AR models. They're generally really good at quality. They basically predict the next word based on all the words that came before.
Like finishing a sentence. If I start saying, the quick brown fox jumps over it predicts lazy dog.
Precisely. Great for coherence. But as you can imagine, doing that one word at a time for a long piece of text.
Takes forever. Yeah, I get that. Okay, so that's the slow but good one. What's the other?
That would be diffusion models. Now, these are often faster. They can generate things more in parallel, not strictly word by word. You've probably seen diffusion used for AI image generation.
Ah, right. Those cool AI pictures. So they're fast, but what's the catch for text?
Historically, the catch was often quality and coherence, especially for longer text. They could be a bit jumbled. And they weren't very efficient with something called KV caching.
KV caching. Okay, break that down for me. Is that like the AI remembering what it just did so it doesn't have to recalculate everything constantly?
That's a perfect way to put it. It's like remembering previous thoughts or calculations to speed things up. Standard diffusion models, especially older ones for text, weren't really set up to do that easily. Made them less efficient than they could be.
Gotcha. Slow and high quality versus fast, but maybe lower quality and inefficient. So the BD3LMs, they bridge this gap somehow. What's the big idea?
The big idea, the aha moment, is generating text in blocks or chunks.
Blocks, like paragraphs.
Sort of, yeah. Think of it like that. Instead of one word at a time or the whole thing at once, it tackles the text block by block.
Okay, building with text Legos, I can picture that.
Right. And here's the clever part. Within each block, it uses a diffusion process to generate the text. That gives it speed.
Okay, diffusion inside the block.
But, and this is key, it decides which block to generate next based on the previous blocks in an autoregressive way, one after the other.
Whoa, okay, so the drafting inside the paragraph is the fast diffusion method, but the overall flow, deciding what paragraph comes next, uses that slower, more careful step-by-step logic.
Exactly. That's why the paper also calls them semi-autoregressive. It's a mix. You get the potential speed of diffusion, but maintain the logical flow and coherence that AR models are good at, just at a block level.
That sounds really smart, actually. It tackles the limitations head on.
It does. And this matters for, anyone listening who actually uses AI tools.
Right. Why should you, listening now, care about this? How does it fix real problems?
Well, remember we said older diffusion models often generated fixed-length text.
Yeah, like only being able to write tweets when you need an email.
Exactly. Imagine a chatbot that could only give one-sentence replies. Not very helpful, is it? BD3LMs are designed for arbitrary-length generation. They can write short answers or long documents.
Okay, that's huge for practical uses, like chat systems, as the paper says. You need flexibility.
Absolutely. And then there's that KV caching thing. We talked about the AI's memory.
Right, making it faster by remembering past work.
BD3LMs are specifically designed to support KV caching effectively. The block structure helps with that, so the AI can reuse computations from previous blocks when working on the next one.
Which means less waiting time for me when I ask the AI to write something.
Potentially, yes.
Yeah.
More efficient generation. Faster responses for you.
Faster and flexible length. What about the quality? You said diffusion sometimes struggled there compared to AR.
True, that was a gap. But the researchers claim BD3LMs achieve new state-of-the-art performance among diffusion models on standard tests. They explicitly say the output is high quality.
So they're closing that quality gap, getting the speed without sacrificing the writing quality as much.
That seems to be the major claim, yes. It's a significant step forward if it holds up across different tasks.
Okay, I'm sold on the why. Now, let's peek under the hood a bit, but keep it simple. How does the diffusion within the block actually work? You mentioned masked diffusion.
Right. Masked diffusion. Imagine you take a block of text, like a paragraph. The AI then sort of randomly hides or masks some of the
I
words.
like censoring bits of it, leaving blanks.
Exactly. Lots of blanks. Then the AI's job is to fill in those blanks correctly. But it doesn't do it all at once. It gradually denoises the block, figuring out the missing words step by step based on the words it can see.
Like sharpening a blurry picture, it gradually figures out the details.
That's a great analogy. It learns to predict the masked words based on the surrounding context within the block, and also, crucially, based on the context from the previous blocks that have already been generated.
And how does it understand the context? Is that where those transformer things come in?
Spot on. They use a transformer network that's a very common and powerful AI architecture now. Think of it as the AI's reading comprehension engine. It helps understand the relationships between words.
Okay.
And specifically for BD3LMs, this transformer uses a special block causal attention mask. Fancy term, but it just means the AI is forced to pay attention to the previously completed blocks when it's generating the current one. It can't peek ahead.
Right, so it keeps the story or argument flowing logically from one block to the next. Makes sense. What about training? The paper mentioned specialized training and noise schedules. Sounds complex.
Training is basically how the AI learns to do all this. They did develop a specific training method for BD3LMs. The noise schedules part relates to how they did that masking during training.
The hiding of the words.
Yeah. It turns out that just randomly masking words isn't always the best way. The strategy of masking how many words, which ones, how often, that's the noise schedule. They found that carefully designing these schedules was important for teaching the AI effectively.
So, like a teacher figuring out the best way to quiz a student, not too easy, not too hard.
Kinda, yeah. They even developed what they call clipped noise schedules. Basically, avoiding extreme masking rates, hiding too few or too many words, helped the AI learn better and more stably. It reduced something called gradient variance, which was apparently an issue.
Okay, so fine-tuning the teaching method helped the AI learn to fill in the blanks better. Got it. So did it work? What were the results like in their tests?
They tested it quite thoroughly. They used big data sets, standard benchmarks like LM1B, and open web text, think massive online libraries of text.
The standard proving grounds for these AI models, right?
Exactly. And the results look pretty good. They measured something called perplexity. Lower perplexity is better. It means the model is less surprised by the next word, so it's better at predicting and generating fluent text.
And how did BD3LMs do?
They showed better scores compared to previous diffusion models they tested against, like D3PM, SEDD, and MDLM. The paper highlights, for instance, up to 13% improvement in perplexity over MDLM on one dataset.
13%. That sounds like a really solid improvement in text generation ability.
It's definitely significant in this field. And remember the arbitrary length thing?
Yeah, writing text of any length.
They demonstrated that too. They showed BD3LMs could generate sequences much longer than some other models, mentioning up to a 10A longer than a model called SEDD on open web text, even exceeding their training data length sometimes.
Wow, 10 times longer. That really opens up possibilities for using AI for like writing chapters, detailed reports, maybe even scripts.
It certainly points in that direction. They also looked at the quality of the generated text using another metric involving GPT-2 large.
Okay, what did that show?
It suggested that BD3LMs could achieve comparable or even better sample quality compared to other diffusion methods, but, and this is important, often using significantly fewer generation steps.
Fewer steps, meaning faster generation again.
Exactly. It ties back to efficiency.
Yeah.
High quality, long text generated potentially faster. That's the trifecta they seem to be aiming for.
Okay, so let's try and wrap our heads around this. BD3LMs seem like a really clever combination. They take the speed idea from diffusion models, but apply it smartly within blocks.
Right, within those chunks of text.
And then they use the more careful sequential logic of autoregressive models to connect those blocks together, making sure everything flows.
That's a great way to summarize it. And by doing that, they tackle those big hurdles. The fixed length limitation, the KV caching inefficiency, and they push the quality of diffusion-based text generation forward.
And for you, listening, the payoff could be significant. We're talking about potentially faster, more capable AI assistants, tools that can help draft much longer documents, emails, maybe even creative stories.
Or chatbots that can actually hold a detailed, coherent conversation for more than 2 exchanges.
Yeah, more natural, more useful AI interactions without you needing to understand all the underlying tech jargon. It could genuinely improve how you work or even just interact online day to day.
The potential is definitely there. It represents a solid step in making AI text generation more practical and powerful.
So here's something to think about as we finish up. If AI like this gets really good at generating long, coherent, high-quality text efficiently, what are some of the unexpected ways that might change things for you? What new applications might pop up in your work or daily life that we aren't even considering right now?
That's a fascinating question. It opens up a lot of possibilities.
Definitely food for thought. Maybe check out the project page linked in our notes if you want to see more. The deep dive always continues.